In the previous discussion, we discussed the definition of integrations, and we also discussed some basic rules about integrations. So, in the following discussion today, we are going to learn what is definite integral, so the definite integrations, and also the properties of definite integrals. So, these are the objective of today's lesson. Right, first we are going to evaluate the definite integrals using the properties of definite integrals. So there are two things here, right? First, the first thing we are going to learn is we are going to evaluate the definite integrals. Second thing is we are going to learn the properties of definite integrals and how to use it to evaluate the definite integrals. So let's start with the first one, definite integrals. So what is definite integrals? The definite integrals is we find the antiderivative of the function, right, from uh, on a closed interval a to b. Now, what does that mean? It means that, right, we are going to integrate the function f, right, from this interval from x equals to a to x equals to b. Okay, so within this interval, usually we write like this, from a to b within this interval. Now, so when we integrate the function of f within this interval, so we are going to write as this, okay, from a to b. So we are going to write the two numbers here. This is what we call the lower limit, and this is called upper limit. So when we write something like this is called definite integrals. Okay, now the definite integrals implies uh, the continuity implies integrability. Okay, what does that mean? It means that uh, when we have a function which is continuous within this interval, for example, okay, let's say we have a function of f. Okay, the function of f is continuous on the closed interval AB. So if the function of f, right, is continuous within a, b, therefore this function is integratable. So we can integrate the function f. Now, if the function f is not continuous, so not continuous within a to b, for example, it's like this. This is a and this is b. Now, we can see here the function f is not continuous on the closed interval a to b, right? It is not continuous. Therefore, in this case, all right, the function is not integratable within this interval. Okay, so the continuity implies integrability. It means that, right, if it is continuous, then we can integrate. Okay, so now the integration, the definite integral, actually represent the area. So when we have, right, integration of function f, okay, so from a to b, now we can see here this is the function f. So when we integrate from a to b, the answer we get actually represent the area under the graph. Okay, so represent the area, all right, of the region bounded by the graph f and the x-axis. Okay, so let's take a look on this example. Okay, so we have this function fx equals to 4x minus x squared, and we integrate this function from 0 to 4. So this is what we do, right? So first when we integrate, So we integrate 4x. So the power is 1 here for 4x. So we add 1 to the power. So this is 2. So divided by 2. Alright, minus. Okay, integrate x squared. So the power is 2 plus 1. And now the power is 3. So divided by 3. Now when we integrate like this, we are going to put the value behind here after we integrate. Okay, and when we simplify here, right, 4 divided by 2, we have 2, so we have 2x squared, and this is x to the power of 3 over 3. Okay, so after we have done the integration, now we are going to substitute the value into the antiderivative. So the 4 substitute here, we have 2 times 4 square minus 4 to the power of 3 over 3. Okay, so when we substitute 4 inside, we have this minus, we have to substitute 0 inside. So when we substitute 0 inside, we have 2 0 square minus 0 to the power of 3 over 3. And of course, we know this is 0. And so when we solve this one, we will have, okay, so this is 16, all right, times 2, 32. Okay, 16 times 2, 32, and this will be 64, 4 to the power of 3 over 3. And now the answer we get here, actually this represents the area under the graph, okay, bounded together with the x-axis. All right, so the answer here is the area. Okay, so remember the area is actually the definite integral, right, of the function within the interval. Now let's take a look on this another example here. Okay, now so the function for this straight line is x plus 2. So if we integrate x plus 2 from 0 to 3, so we integrate the line from 0 here all the way to 3. Now the answer we found is actually the area, all right, under the graph, which is the trapezoid. Okay, now so if we integrate, so what do we have? So first we have x, all right, power is 1 plus 1, we get 2 divided by 2. And we integrate this one, 2, we get 2x. So after that, we are going to put the value 0 and 3 right behind here. Okay, so now we are going to substitute the value into the function now. So 3 substitute here is 3 squared over 2 plus 3 substitute here is 2 times 3. Okay, minus, we substitute 0 inside. Now, if we substitute 0 inside, we get 0 here. If we substitute 0 into 2x, we also get 0. Therefore, the whole term is 0. Okay, solving this one, we will get 9 over 2 plus 6. Alright, actually this is, alright, we have 9 over 2 plus 12 over 2, we get 21 over 2 unit, okay, square. Right, now this is the area of the trapezoid. Now, we can also use the formula to prove that, alright, the answer we get here is actually the area. Now, how to find the area of a trapezium? Now, it will be the area, right? Since we know the formula, it will be 1 over 2, all right, A plus B. Okay, so the sum of the two parallel lines, which is 2 plus this one is 5, and multiply the height. The height is 3. Okay, so if we use the formula, the area will be 1 over 2. All right, 2 plus 5, multiply the height, which is 3. And this gives us 7 times 3, 21 over 2. All right, so if we use a formula, we get this. And if we use the integration, we'll also get the same answer. So this verified that the integration is area. So after we know that the definite integration and also the meaning of definite integral, right? The definite integral is actually the area under the graph. Now we are going to learn some properties of definite integrals. Okay, number one, all right, if we integrate the function from a to a, all right, we will always get 0. Now the a is actually a number, so it means that if we integrate any function, right, from let's say 1 to 1 or 2 to 2 or 10 to 10, any value, right, but they are actually the same value, right, we always get 0. Now what does that mean? Okay. First, since we know that the integration is actually represent the area, so if we integrate the function from 1 to 1, actually means that we are getting a straight line. We are actually finding the area of a straight line. Now let's say this is function f and this is 1. So if we integrate, right, the function from 1 to 1, okay, we are actually finding the area of a straight line. So what is the area of a straight line? The area of a straight line, of a vertical line, is actually 0. Okay, so the area is 0 when we have a vertical line here, right, from 1 to 1. Now the second properties, now if we integrate function f from b to a, this is equivalent to the negative of integrate the same function from a to b. Okay, so if we change these two values, means that if we change these two values, right, we have to apply a negative in front. Okay, so let's take a look on the example 4. Right, question A. Okay, integrate sine x from pi to pi. Okay, now as we can see here, these two values, they are same value. So when we integrate a function, okay, from a value to the value itself, we always get 0. So there is no working here. Okay, so always get 0. Now number 2, okay, question B. Now if we integrate x plus 2 from 3 to 0, so this is according to the properties. This is actually the negative of 0 to 3. We integrate the same function. Now actually these questions, we already obtained the answer in the previous calculation. Alright, this one. Alright, from 0 to 3, x plus 2. So the answer we get is 21 over 2. And now we can apply the answer here. Since this one is these two value, we swap, right? So we get negative, right, 21 of 2, right? This is actually 21 over 3, sorry, over 2, right, 21 over 2, then we have a negative in front. So this answer will give us a negative 21 over 2. Okay, so we have this, right, the 0 for question A, and negative 21 over 2 for question B. Now the next properties of definite integral will be, okay, so if we integrate a function from a to b, and c is between a and b, all right, c is between a and b, therefore this is equivalent to we integrate the function from a to c plus we integrate the function from c to b. Okay, so we can use a graph to explain this. So now let's say we have this function. This is function f. Alright, So the function f, okay, so let's say this value is a, this value is b, and there is a value c in between. So, for example, if we integrate a to c, integrate a to c, we are actually finding the area here. So maybe I just will put m. Okay, we are actually finding the area for m. So this is the area for m, right, a to c. And if we integrate c to b, right, from c to b, the same function, we are looking for the area of n. Therefore, if we are integrate the function from a to b, right, from a to b, now we know that we are finding the area, so it will be m plus n. Okay, the area will be m plus n, and it will be from a to c plus c to b. Okay, so this property says that, okay, when we integrate the f from a to b, and c is a point in between, so this is equivalent to we integrate the function from a to c plus integrate the function from c to b. Okay, so let's take a look at this example. Okay, so when we find the area, right, from a to c, right, we integrate from a to c the function f. Okay, we get this area. When we integrate c to b, right, c to b, the function f, okay, we will get this area. And when we integrate from a to b, the whole thing, right, the function f, right, we can sum these two areas to get the integration from a to b, right, from a to b, we can just sum these two. Okay, because the line segment has zero area, it follows that the area of the larger region is equals to the sum of the areas of the two smaller regions. Okay, so the area of the larger region is the sum of two smaller regions. Okay, now if we integrate the absolute x, right, from -1 to 1, so we can actually split this into two. Now, what is a function of absolute x? So if we remember absolute x, the graph is like this. So absolute x suggests that the y is always positive. Okay, when the y is always positive, it means that when the x is 1, the y is 1. But when the x is -1, the y is still 1. Alright, so after absolute, we always get a positive number. So this is actually the graph. Now, if we split this graph into piecewise defined function, alright, the equation will be y equals to -x. Alright, this is the equation for the negative side. And as for the positive side, here the y will be equals to x. Right, when the x is 1, the y is 1. Right, and here when the x is -1, so the y will be negative of -1, and we get the answer 1. The y is 1. Okay, now since this function consists of two different graphs, so when we find the area, we need to split it into two, and the area will be, all right, from -1 to 0, which is this area, from -1 to 0, plus 0 to 1. Okay, so when we integrate from -1 to 0. We use this line, so we use the negative x. Okay, so -1 to 0. This is the function, so we use negative x here for the integration. Okay, plus on the positive side from 0 to 1, here, okay, we are using this function y equals to x, so we are using the x. Okay, so integrate this, and therefore we have, right, integrate this one. Okay, let's work out the solution. Right, we have 1 power 1 plus 1 is 2 divided by 2. Okay, we have -1 to 0 plus this one is x squared over 2. Right, the power is 1. 1 plus 1 is 2 divided by the new power is 2 from 0 to 1. And right, by doing this, now when we substitute 0, we get 0. When we substitute -1, then we get negative. Okay, negative. Okay, we have actually 0 minus negative 0 minus negative of -1 square over 2. Okay, plus when we substitute 1 here, we have 1 square over 2 minus 0 square over 2. And this will give us, okay, 1 over 2 plus 1 over 2, which is 1, All right, so from here we know that the area is 1. Okay, now, right, so my answer will be, okay, right, the answer is 1. Now, from the graph also, we will know that the area should be 1 because this is half of a square and this is another half of a square. So when we combine these two, we will get 1 square, right, which the area is 1. Okay, the next properties of definite integrals. So if we integrate k fx from a to b, so the k is a number, so we can just put the k aside. We only integrate the function f from a to b, right, with respect to x. And if we integrate the function f plus minus g, right, from a to b, we are going to integrate them separately, right? The operation plus or minus, we follow the same. Okay, so where we have this example, evaluate -x squared plus 4x minus 3 with respect to x from 1 to 3, right, using the following values, right, when we integrate x squared from 1 to 3, we have 26 over 3. When we integrate x from 1 to 3 is 4, and when we integrate 1 dx, okay, when we have nothing here, it means that it's 1 dx. From 1 to 3, the answer is 2. Okay, so let's use the value to evaluate the function here. So we integrate x squared plus 4x minus 3 with respect to x. So we can integrate them separately. First, we integrate, okay, x squared dx plus, now we integrate the second one. Now the 4 is a coefficient. We can just put it aside, 4. Okay, we have x power 1 plus 1, which gives us 2. Okay, this is power 1. Right, this one which gives us 2, but we are going to do it later. And then we minus, right, we integrate, okay, 3 we bring out, we integrate 1 dx. So, solve this, okay. Now, as we can see here, this one, integrate x squared from 1 to 3 is here. So the answer is 26 over 3. So we have negative 26 over 3. right? And the second part here, integrate x, we have this, right, from 1 to 3. Okay, from 1 to 3. Integrate x from 1 to 3. The answer is already here, it is 4. So I'm going to plus 4 times 4. Okay, and after that, the one minus. So minus, this minus is here. So 3. Now, as we can see here, integrate dx from 1 to 3 is here. Integrate dx from 1 to 3. The answer is 2. So I'm going to multiply the 2 here. And so finally, solve this one. Right, we can get the answer for this. Okay, let's take a look on the formal answer. Okay, so first we split this. Right, right. So then take out the negative, take out the 4, and take out the negative 3. So this one is 26 over 3. This is 4, and this is 2. And solve this one, right, the answer is 4 over 3.